Welcome to Day 3 of the System Design Interview Guide. Today we're going to dive into Day 3, Load Balancing. To really cement how load balancing works, it helps to step away from the servers for a second and look at a real-world scenario we have all probably experienced. Picture walking into a chaotic, incredibly busy hospital. The very first person you run into is the receptionist, and how they direct patients is actually the perfect way to understand a basic, naive load balancer. Let us break down how this hospital setup works and why it is so similar to our software systems. To make this work, our receptionist needs a solid strategy, like looking around to see which doctor has the fewest patients waiting and sending the next person there. Or they could keep it super simple and just take turns, sending patient 1 to Dr. A, patient 2 to Dr. B, and so on, in a continuous loop. But if a really complex case comes in, they will likely route them to a senior specialist with more experience. In the tech world, these are the exact same strategies we use for load balancing, which we call least connections, round robin, and weighted routing. Think about walking into a busy hospital with 5 doctors on duty. The receptionist at the front desk does not just send every single patient to doctor number 1, leaving the other 4 sitting idle. Instead, she smartly distributes the patients among all the available doctors so everyone gets seen quickly. In the world of system design, a load balancer is exactly like that receptionist, but for your servers. Now that we have a good grasp of how a simple receptionist handles things, let us take a look under the hood. We are going to roll up our sleeves and really get into the nitty-gritty of how this works in a real production environment. It is time for a proper deep dive into the actual architecture, so grab your coffee and let us get into it. So now that we have covered the deep dive, let us talk about the ultimate traffic cop of system design, the load balancer. Think of it as a smart middleman sitting right between your users and your backend servers, handing out incoming requests so no single machine gets overwhelmed. This is huge because if one of your servers suddenly crashes, the load balancer instantly redirects traffic to the healthy ones. Plus, it lets you easily add or remove servers behind the scenes without your users experiencing a single second of downtime. So, where do we actually place these load balancers in a real-world system? It is not just about putting one at the very front gate to handle incoming user traffic to your web servers. In a typical setup, you will actually see them layered throughout your entire stack, sitting between your web servers and application servers, and even between those app servers and your database. This ensures that every single transition point in your network stays balanced, highly available, and ready to scale. Now, here's where we get tactical, namely, where do we actually slot these load balancers into our system? The most common spot you will see is right at the front gate, sitting between your users and your web servers to handle that initial wave of internet traffic. But we can also place them deeper in the stack, like between our web servers and internal application servers, or even between those app servers and our databases to keep our queries balanced. Now, here's where things get really interesting. You do not just put a load balancer at the front door of your application and call it a day. In a robust system design, you can actually place them at every single tier, from the user interface right down to the database layers. This means every step of your stack can handle traffic smoothly and stay incredibly resilient. Now that we know where to put these load balancers, let's look at the actual strategies they use to distribute that traffic, starting with one of the most common algorithms. It is called round robin, and it works exactly like it sounds, sending the first request to server 1, the second to server 2, the third to server 3, and then looping right back to the beginning. This is a fantastic, straightforward option if your servers all have the same hardware capacity and you are handling stateless requests where you do not need to track user session history. Now that we have our routing algorithms down, we need to talk about where these decisions actually happen in the network stack, which brings us to the classic comparison between Layer 4 and Layer 7 load balancing. To put it simply, Layer 4 operates at the transport layer, making lightning-fast decisions based solely on raw TCP or UDP packets without looking at what is inside them. Layer 7, on the other hand, is much smarter because it operates at the application layer, allowing it to inspect HTTP headers, URLs, and even cookies to route traffic with incredible precision. To really bring this to life, let's look at a classic example of Layer 7 routing in action using a URL path. Imagine a user goes to your website.com/video. Because a Layer 7 load balancer can actually read the HTTP request, it sees that /video path and instantly routes that traffic to your dedicated video streaming servers. It is incredibly smart and ensures your resources go exactly where they are needed most. Now, to see this Layer 7 magic in action, take a look at how we can route traffic based on the actual URL path. For example, when a request comes in for user-related data, the load balancer directs it straight to our dedicated user service. If a customer is placing an order, that request gets routed to the order service, while any requests for static assets like images are sent directly to a CDN. This kind of smart routing is what keeps our backend architecture incredibly clean and highly efficient. So, once our load balancer is routing traffic, we have to ask ourselves what happens when one of our backend servers actually goes down. This is where health checks come into play. Essentially, the load balancer needs a reliable, continuous way to detect if a server is struggling or completely offline so it can instantly stop sending user traffic there. To see how this looks in the real world, let us walk through a quick example. This is a basic health check endpoint that does a lot more than just check if the server is turned on. It actually tests our live database connection and our Redis cache to make sure they are both responding. If either of those dependencies fails, it immediately flags the server as unhealthy, so our load balancer knows to stop sending traffic here. So, we have this amazing load balancer distributing our traffic, but what happens if that load balancer itself actually goes down? To keep things running, we set up a backup system where a primary load balancer handles all the work, while a secondary one constantly checks on its health using a heartbeat signal. If the primary suddenly fails, that secondary backup instantly steps in and takes over the traffic using a floating IP address, so our users never even notice a disruption. To make sure a failing load balancer doesn't take down your entire system, we usually set up a backup using one of two strategies. First, there is the active-passive approach, where a standby load balancer just waits in the wings, ready to immediately take over if the main one goes offline. Alternatively, you can go with an active-active setup, where both load balancers are working simultaneously, sharing the traffic load and keeping things running smoothly. Now that we know how to keep our load balancers from becoming a single point of failure, let's talk about how you actually pitch this in a real interview. It is one thing to understand the tech, but knowing how to articulate it clearly is where the magic happens. Let's walk through exactly how to explain this concept so you sound like a seasoned pro. Let us look at a concrete example of how to put this into practice during your actual interview. You could say something like, I would place a Layer 7 load balancer here to handle content-based routing, letting us send API requests to our app servers and static content requests straight to our CDN. A phrase like that is incredibly powerful because it immediately shows the interviewer you understand the practical, real-world mechanics of routing traffic. So how do you actually pitch this concept during a real system design interview? You will want to say something like, for our load balancing algorithm, I would recommend using least connection since our requests have highly variable processing times. This is a great response because it shows the interviewer you are thinking about real-world traffic patterns and preventing server overload, rather than just choosing a default option. Interviews say, we need to ensure the load balancer itself isn't a single point of failure, so I'd set up an active-passive pair. Now that we have a solid grasp of how to build things the right way, let's flip the script. In system design, knowing what not to do is just as critical as knowing the best practices. Let's dive into some of the biggest traps and red flags you will definitely want to steer clear of. To wrap up what we want to avoid, there are 3 classic load balancer pitfalls that can instantly trip you up in an interview. First, don't treat the load balancer itself as a magic bullet, because it can easily become a single point of failure if you don't design for redundancy. Second, avoid blindly choosing a basic round-robin algorithm when your system has to handle requests with wildly different processing times. And finally, make sure you mention health checks, because the interviewer is actively waiting to see how you plan to detect and route around failed servers. Now that we have those fundamentals down, it is time to put together a concrete action plan. Let us walk through our Day 3 checklist so you know exactly what to focus on next. This is where we take everything we have learned so far and start putting it into practice. Know all 6 load balancing algorithms and when to use each. Understand L4 versus L7 differences. Always mention health checks. Address load balancer redundancy. And that wraps up day 3. Make sure to review the concepts we covered today, and I'll see you tomorrow for day 4. Don't forget to like and subscribe.